talking about here is dividing. And dividing as a mathematical device, pretty easy. Lots of ways to do it. If you're going to do it to be held in the grip of a machine while you're cutting steel, that's a different matter. So that's what we have. We have a dividing head, which is a very rigid device for moving your workpiece around in a circle, so that you can either make particular angles or, as is common in gears, just make equal divisions. All right, now, the way this basically works is, you basically are dealing with a worm. I think I'm going to want to put in too much detail. And a worm wheel. Okay? And the ratio here is 40 to 1. This goes around one turn. This moves 1/40th of its circumference. That's one of the basics of dividing. It could be 60, it could be 90. Many rotary tables are 90 rather than 40. And other companies like Cincinnati had a 60 ratio. But for Brown and Sharp, which is what I did most of my work with, it was 40. So you just have to remember, one turn of this crank, you're rolling crank on the engine. One turn of the crank, 1/40th of a turn around. Okay, so you start out, and that makes it very easy to divide a circle into 40 parts. Just go around one time with the crank, cut, another one time, cut, and you'll have 40 cuts around equally spaced. The simple ones are not usually a problem. It's when it gets a little more complicated. What you're basically going to do now, and what the dividing head, and this is a little small for you to see in the back, you have a crank, okay, and the plunger comes out and it goes around. The plunger goes back into a hole. You've got plates with circles of holes. Okay, now, depending on the number of holes, you're dividing that whole turnaround into however many parts it is. I have to pick up 21, 23, 27, 29, 31, 33. That's how many. There's six circles of holes here. That's how many different ways I can divide up that 1/40th of a turn. So, you know, I could, let's say I had 20 rather than 21. Okay, I could go around 20 holes, or I could go around on a 20-hole circle, 10 holes, and then I'd be going around half of my 40th. So instead of 40 parts, I'd wind up with 80 parts. That's fairly simple. You start getting into complicated numbers of divisions, and you look up in the table to see how many holes that number of divisions gets you. Now, let's make ourselves a big plate here. Okay. So if we have a series of holes, and we're going to make it simple, You only go halfway around. Okay. Or you could go, how many did I draw here? 3, 8. Okay. So I can divide this 40th into 8 different parts. That just gives me more opportunities to finally divide up the circle. And we can look at the table and see how many divisions you wind up getting with that number of holes. Now, so far there's nothing new in what I've described. This is just explaining what the deal is. What I did was take a technique which used not one circle of holes, but 2 circles of holes. So, okay. Now, what happens when you use 2 circles of holes? Now, instead of saying I've got 20ths, because I've got 20 holes in the circle, I have 20ths and, 30ths. 20th and 30th. If I could use both of those at the same time, I could then get a much larger number of divisions. I could make divisions that I couldn't make just using one circle of holes. And that's basically what I did was I codified that process I mean, it's an old method. It's been around for 100 years. It's been around for 100 years. 15 years ago when I started working on it. And there were some solutions whereby you use 2 circles of holes, 2 cranks, and you could get divisions that you couldn't get otherwise. But unfortunately, when you looked at the books that described that process, there were a number of problems. One, they didn't have solutions for all the possible number of teeth you might want in a gear, the number of divisions that you might want. They just didn't have them. They complained that the calculations that were required to find the ones that there were was prone to a lot of error. And they said, but your dividing head only has sector arms for 1 circle of holes. The other circle of holes, you're going to have to count holes. So I said, okay, if that's what the problem is, then we can solve those. First thing I did was I used my computer to come up with all the exact solutions for compound indexing with the Brown and Sharp plates. That's 3 plates with 6 circles each. Okay, that's a certain 18 number of circles that can be dealt with. Okay. First thing I did was I came up with all of the exact solutions for compound indexing on those 3 plates, which added 22 more to what was known. That was just because people just didn't know. I mean, then they had to work it out by hand. You can see why they might not have gotten very far. And then the next thing I did was I said, okay, how close do I have to be for it to count? And, if I could get to 3 or 4 nines, like 0.9999 of the right answer, that's good enough because our machines don't get that good anyway. So I went through and I did the calculations required for all of the divisions up through 400. And some of them, there are about 4 that I think are a little bit flaky. 4 out of 400 is bad. And all the rest, I was able to get multiple good solutions for using 2 circles of holes. And I codified them. I sorted them out, got the best one I could get, and then maybe one that's pretty easy, not the best, because I figured sometimes you're going to want to make a gear directly from, you're going to have your dividing head, you're going to be cutting, you know, all the way through to the final gear, and you want the best divisions you can get. But other times, you might just be doing the gashing for a subsequent operation, say, free hopping. So you want to have a gash in all the right places, but you're not cutting down to the final size anyway, so you don't need it quite so good. So that table of divisions up to 400 was published and is available to anybody. Certainly anyone in the club that needs an answer can give me a call. But it was published in Home Shop Machinist, and that article has now been, you know, put into Projects 8. So it's available. People now know what the solutions are. So instead of it being in a situation that, well, you got this formula you can work out, and gee, it doesn't quite come up with good solutions in half the time, but you got the other half you can shoot for. And of course, everybody was saying, no one ever told you which half was which, and you didn't know. So you had a particular division you wanted to make, you had to go through the drill. So now it's all done, that part. Okay, so that now came to the next question I got from my colleagues out there on the internet, saying, but how do I do compound indexing? There's only one pin on my dividing head. So I designed a second pin, and that's here. And you can come up and look at it later. I can lift this, but it's, yeah. There is, in addition to the regular pin, there's one that screws out, screws in, and allows both the other pin and plate to move a certain number of holes, and then this tightens up again. So you've got that second pin that you need to be able to do the second circle of holes. Which, once I started doing it, I realized that the regular pin that came with your dividing head didn't expect to have to share space with another pin, so it was big and clunky. So I made one that was nice and slender so that I could get 2 going directly into holes very close to each other on adjacent circles of holes. So you have a more slender pin, you've got a second pin that you can use for the second circle of holes, and now you can do both holes. But there was still the complaint, but you only have one set of sectors. Sectors are a tool see them from there. Let's draw them up on the board. What that's behind it, and that one's going out. There. So you're marking off on a circle of holes, a number of holes that it's going to go. 1, 2, 3. So the next time after you have to make, after you move the arm, then this just slides around, and it's always marking off 3 holes on that particular circle of holes. So you don't have to count the holes, you know, the right spaces between there. But they said, but you only have one of these. And you need 2 if you're going to have 2 pins. So I designed a set of, from very short, where they might ride on adjacent inner circles, very, very short arms, and it goes up to somewhat larger. Each one goes to a successive circle of holes so that it can track an inner circle, whereas this one's on an outer circle. And it can run at the same time as this one's running on one circle of holes, this can run on another circle of holes. And of course, they both run on the same plate. So you've got them running together, and you know, depending, who knows how many holes it is, but one runs and takes care of one circle of holes, and the other one runs for the other pin, takes care of the other circle of holes. And the only problem I had was, that's in order to fit, it's a nice thin package, there's no room for a screw. And I worried about that one for a while, until I came up with rubber cement. You set the sector to the number of holes you need. You put a little dab of cement around it. You stick it. 5 minutes later, it's good for the rest of the project. You do the other one, however much it needs. You stick it, and it's good. The only problem with that rubber cement is, don't forget about it. When you're done with the project, you want to separate them off, because if it's there for 6 months, you might have to make new pieces of brass, because they'll be stuck real good. So that solved that problem. Indeed, it solved all of the known problems about compound indexing. We don't have to do calculations, they're all done on the table. We've got a second pin, we've got a narrow pin so it doesn't interfere with it, and we've got dual sectors. Now, one more thing that I did as I realized that I could. When you do the math and you get the solutions, about half the time you've got, you know, 2 circles all the way around and 5 holes on the 37 circle hole this way, and then 1 turn and, you know, 17 holes going the other way on the other circle of holes. Now, they have a name for it. It's called negative compounding. Almost all the negative compounding solutions can be converted algebraically into a positive compounding and avoid having to whip the backlash back and forth for each movement, so that you can be constantly going in the same direction. You move one crank, you set it, you go to the other crank, you're in the same direction, you move its number of its length of turn, lock everything down, make your cut, loosen everything up, make your move again, lock everything down, make your cut. So that's wound up being an improvement that I didn't realize when I had first done it. I didn't realize I'd almost always be able to find that positive compound solution. And sometimes you didn't want to. Sometimes it was so simple that there really wasn't an opportunity to convert it, because it was, 3/15 and 2/17, And at that level, you said, well, we'll worry about the backlash, because that's just too easy to, you can do that, so easily. Whereas there's no room to go around. You'd have to add many turns to be able to do that. So that's compound indexing. It's a way that plain dividing head will do all the divisions you need. It won't do everything that the universal dividing head does, but it will do all the divisions that they do. If you want to make helical gears or other things like that, you do need to have the universal with its gear attachments and so forth. But for just division purposes, it can all be done here with a plain dividing head. Yes?
The disc is free to move now, right?
The disc is absolutely free to move. It has to be free to move. Those three holes that used to contain screws, you take those screws out, you put them in a drawer, and you forget about them, because you're never going to need them again. Even if you're doing simple compounding, you just put this in a convenient place, and that'll hold the plate. You don't need the screws to hold the plate.
The plate is free to rotate, though.
It's free to rotate only if both pins are out.
Okay.
You see, if this goes out and this is out, then this will go wherever it wants. But you'd almost never have both of them out at the same time unless you did it intentionally.
Okay, so all
So when I pull it out, then this goes around, but that doesn't move. Or this comes out, okay, and then this moves with the plate.
Okay.
And those are the two moves that you make. Yes?
Two questions. Anyway, why do you have to make the pin narrow? Is it because the two won't align on the same plate, and you need a little?
No, because this one is made narrow because the one that had been there was shaped like this and occupied 3 circles of holes worth of real estate.
Oh, okay.
Which doesn't always get in the way, but sometimes gets in the way
Oh, okay.
of the other pin being able to get by.
Oh, okay.
So it was just, it's a very simple project. It's not like it takes a lot of time or effort.
Now, the one for the compound indexing, that pin screws out and then screws in. You don't have it spring loaded, do you?
It is spring loaded.
Oh, it is?
It's spring loaded, and I just use that, it's knurled, and I just, use that to loosen it up so that it is disengaged from the indexing plate.
Oh, okay.
Yeah, but it is spring loaded.
Okay.
Again, it's not a complicated, chore.
I can't see it from here. I'll
Yeah,
look at it later.
right. But when you come up afterwards, you'll be able to take a look at it.
There's no backing up. Everything is done in the forward direction, though, right?
That's what's called positive compounding.
Okay.
Okay. There is negative compounding, in which each move consists of, or each what's that called, move? Okay. Each turn consists of 2 moves, one going clockwise and the other going counterclockwise. And when you're doing that, that's negative compounding, and it means that each time you move, you must, allow for backlash, the extra movement to make sure that you've taken all the backlash out and then going forward cleanly. which is just another way to make error, make error happen, so.
Can you do the 127 tooth on there?
Absolutely. Absolutely. There are three good solutions for that. Oh, geez, I don't have my reading glasses on, but 127. Okay, I give two solutions here. 2/39ths plus 42/47ths. Okay, and that's an okay. Okay, and the next one is 2 full turns and 23/39ths plus 12/49ths. And that's extremely good. And you can look and see, and I created measures of how good my approximations were, so I could sort them out and pick the good ones. And, just a matter of how much off of them. There are, in these things, small amounts of bobbles that will occur that I have been unable to really nail down, but they're below the level. Okay? They occur in what I will call cycles. That is, maybe 9 of your moves will occur together, and then a slight change, and then another 9, and another 9. Because if in the process of making your moves, you go around full turns, you aren't putting the teeth right next to each other time after time after time. Putting tooth here, tooth here, tooth here, tooth here, tooth here, tooth here, and then it isn't until you get toward the end that it begins to fill in. Okay? And in that process of how many times around it goes, I think there's one of the N around is usually a smidgen off, but it's a smidgen off below the level that you're going to pay any attention to while you're machining. So, other questions?
Wow, that is an awful lot of stuff to absorb.
Well, you have the magazines that you can borrow from Don, although he may want to rent them to you now.
Well, let me go on with my question. If you need 2 circles of holes to solve a complex dividing problem.
Okay.
And I think you read off an example there where you needed a 39-hole circle and a 49-hole
Yes.
circle. And what if you don't have those 2 circles on the same plate? As I think you typically don't.
Okay. What I can tell you is that in devising the solutions that I put in the table, all pairs were on the same plate. It was not a solution to have one on a plate over here and another one, next door. They both have to be on the same plate.
picked up on that, because otherwise it wouldn't be. I don't think it would be very much.
It wouldn't. And if I had run into serious problems, like maybe a third of them unable to be solved, I might have come up with 2 plates back to back. Could have solved some problems too. Okay? But I didn't need to.
You're just using the standard plates number 1, 2.
I'm using the standard Brown and Sharp plates that everybody has. Right? It's the only thing. Some people say, "Well, I'm making my own. I'm going to make one different circle in there because it solves some particular problem I have." And what I tell them is, it may do that, but it may mean that you can't use half of the entries on my tables because I'm sticking to the standard plates.
Have you considered doing one for the Cincinnati plates that have the 6 rings on or whatever it is?
the Cincinnati plates was the accurate angular indexing using compounding. Okay, I didn't do another set of standard of simple and compound indexing, because no one was paying. No one was paying. Machinery's Handbook paid me $400 a page for the Brown and Sharp. Okay, they didn't want a Cincinnati table too, but when it came to doing the accurate angular indexing, they had it both the Brown and Sharp and the Cincinnati. So, but they wanted it like the 3 digits of accurate angular motion. And I told them, you know, if you had more room in your handbook, I could give you 4 digits and probably not miss a beat, you know, from 0 to 1. But they settled for thousands.
On the Cincinnati plates, there are more rolls of,
More circles.
there are more circles, right?
And they're high number plates.
The 127 tooth issue is on one of the plates. In other words, the way they get around it,
Yes. This is just one of a myriad of varieties of dividing devices out there. Okay? There are just lots of them. One of the solutions is to have a 127 tooth circle.
right, but that only just takes care of that isolation.
Takes care of that one,
Yeah.
you know, I mean, okay, I don't mind. But I did the Brown and Sharp. I could have done more if there was more interest. I could still do more if there was a lot of interest, but there isn't, because I still have the program that I could run. But if you can do them all, if you can do all of them with the Brown and Sharp, no one's going to be, you know, hankering for the other.
Let me ask you another question here. This has been, you said this has been around for 100 years. I mean,
Compound indexing.
Compound indexing.
Yes.
How did they do it in the old days? Was there provision in some of the heads to do it already?
There were pins elsewhere available on the dividing head for a second.
Coming from the back side or something like that?
Some came from the back side, some came from, you know, from separately on the, you know, hooked onto the table, you know, not necessarily on the head itself. But very little of that information made it into what I would call the modern era. Okay? Nobody who bought a dividing head in the last 30 years had a clue as to what you would do to get a second pin on that darn thing. I mean, there was nothing about it and no apparent provision for it. Indeed, there used to be on the sectors, see, you had sectors, and everybody had one set of sectors. If you look in Machinery's Handbook, there's a table there which says indication on sector, or index on sector. Okay. The folks at Industrial Press went back as far as they could and tried to find out where in the hell did we tell people what index on sector meant. Now, we know what the sector is. It's one of these. Nobody has had an index on these sectors in their memory. I got a call from the editors at Industrial Press who had taken over from Bob Green, who was the editor that I had worked with. Bob had retired. And in their desperation to figure out what index on sector was, Bob said that they should call me. Who received the phone call. I was on detail at the time at IRS, and I get this call out of the blue. And I said, Sure, index on sector is da-da-da-da-da-da-da. Would you like a picture of it in the morning? By email. I was the only person apparently left on the planet who knew what the hell it was. Which was nice, because after 8 years, having been published in Machinery's Handbook, they hadn't put my name in. As a result of index on sector and the picture I sent them, they put my name in one time.
So I'll ask, what does it really mean?
What does index on sector mean?
Yes.
It means that the sector has little markings around the edges and, you know, an index mark, okay? And so instead of having to count holes even once, you just move this until the index mark was opposite the number that was listed in the handbook, okay? And then you had the right number of holes between them.
Was there graduation on that?
There's a graduation on one, and an index mark on the other, and you just, you know,
Okay.
you moved it around and you got it to where it's supposed to be. You know. Then you tighten your screw because you only had one of them. They were screw tight.
That would serve as one of the rings?
Well, at the time, under that technology, there only was one because nobody was doing two. Even the people who were doing compounding were counting that other set of holes. That was before me.
Where did you get your picture that you sent the guy?
Out of a very old book.
Straighten me out.
You know, I mean, just because I know about it doesn't mean the rest of the world does. I mean, that book was once there were probably thousands of them. But there weren't any left.
Where did you find the book?
I had found it at some, you know, hole-in-the-wall bookstore years and years ago. And of course, I saved that sort of stuff. So, but the real answer, I have to admit, okay, confession. The real answer is I knew the answer because someone else had asked me the same question 4 months prior. That was the real answer, the real reason I knew the answer. I could have done it for them too, but I couldn't have done it quite so instantaneously.
Yeah.
Yes.
I've worked with 2 brown and sharp dividing heads, one of which I have, and they both have those divisions, so maybe they're very old.
They're fine, that's right.
Take a picture.
It's not,
Okay.
well, I mean, you could take a picture, but I mean, they have a picture now.
Yeah, yeah, yeah.
But yeah, that's the point. The point is that no one left at Industrial Press knew what it was about. You knew what it was about because you got them.
Yeah.
So,
You really lost me at one point, Rich, when you said you took the 3 screws that would hold the index plate in and threw them away.
I did not say I threw them away. I said you put them in a drawer and you forget about them. That's
Same
different.
Now, you're decoupling the plate from the spindle of the index?
Absolutely.
Because he's got the extra finger.
I've got the extra finger to hold it in place.
Yeah.
And during half of the movements, I have to leave the normal pin in there, take the new pin out, and move the plate and the first pin around for however many holes it's going to move on the second pin. You see? So it has to be able to move. If it's screwed in, it don't go nowhere.
I'm going to have to sleep on that.
You can come up here and we can show it to you so you don't lose any sleep.
Sure.
Is that pin solid enough that there's no flex in there? Is that pin solid enough so there's no flex in there?
Both of these pins are solid. I mean, they're steel, okay? Do they have some flex? Well, yeah, but not enough to worry about.
Hey, Reg, it's getting pretty late. Why don't we just call the meeting? But would you be willing to do a demo? Just basically show the mechanism and
Oh, I can show the mechanism.
everybody to gather
Sure.
around.
Sure. What I'm not going to do is put these things on, you know, and all of that because it just gets, and any one particular, you know, value is no particular